For the first time, SpaceX has shipped a vacuum-optimized Raptor engine to its Boca Chica, Texas Starship factory, days after the companies present reiterated plans for an inaugural orbital launch attempt, as early as July. Back in March 2021, CEO Elon Musk confirmed that he'd set SpaceX a goal of attempting Starship's first orbital launch no later than the end of July, around 4.5 months distant at the time. In this video, we are going to look. Super Heavy Booster 3 was lifted onto a transport mount and stacked in the high bay for upcoming test, and we are also going to look at SpaceX a weeks ahead to fully assemble Starship S20, a process that has yet to begin. 15 weeks later, though the prospects of an orbital launch attempt happening in July have practically shrunk to zero. SpaceX COO and President Gwynne Shotwell, best known for acting as a more grounded foil to Musk's often impractical schedule estimates, reiterated that the company is still shooting for July for Starship's first orbital launch attempt. As of late June, hitting the target would require SpaceX to string together numerous extraordinary feats of engineering and rocketry in record time, or attempt some extremely unorthodox corner cutting. The launch pad and launch vehicle hardware needed for Starship's first space shot are currently far from ready for flight. On June 24, Musk unexpectedly revealed that the Super Heavy Booster prototype SpaceX is now in the late stages of assembly isn't actually the booster that will carry Starship on its first space launch attempt. In other words, though dozens of rings in various states of work are strewn about SpaceX's Boca Chica factory, the company has being fully stacked the massive 65 meters, approximately 215 feet tall, booster required for the first orbital launch attempt. Using Super Heavy Booster 3 B3 as a ruler, assembly could easily take 9 to 10 weeks, starting whenever the process actually begins. If SpaceX started stacking Booster 4 today, in other words, it's unlikely that the rocket would even be complete by the end of August. Barring SpaceX taking unprecedented shortcuts, completing the booster is just part of the process of preparing for flight, and B4 would still need to be qualified for flight, likely involving at least one cryogenic-proof and static fire test. In a best-case scenario where SpaceX begins assembly today, manages to have Booster 4 assembly time in one fell swoop. This sneaks the second Super Heavy ever completed through qualification, testing, in a single week. The orbital flight test booster still wouldn't be ready for Starship installation, likely another unprecedented first before mid-August. That would then leave SpaceX 5 or 6 weeks to fully assemble Starship S20, a process that has yet to begin. Like Starship SN20, which Musk said sported hundreds of improvements, Musk has also stated that Ship 20, and all after it will feature another batch of upgrades needed to take Starship orbital. Starship SN20 was very gradually stacked and assembled over the course of almost 4 months, though that slow assembly can likely be blamed on the fact that SpaceX is busy testing Starships SN8 through SN11, and was effectively waiting to see if any other major changes might be required. While most of S20's upgrades are a mystery, the ship's thrust dome, spotted in work at Boca Chica earlier this month, has already confirmed that the prototype will be the first, with the necessary hardware for Raptor vacuum engine installation. That likely means that S20 will also be the first Starship to attempt to static fire 6 Raptor engines, potentially producing more thrust than a Falcon 9 booster. On June 27, one such vacuum-optimized Raptor RVac arrived in Boca Chica for the first time ever, making it clear that the comparatively brand new engine may already be ready to start integrated Starship testing. Of course, beyond Starship and Super Heavy, SpaceX also has a great deal of work left to get the rocket's first orbital-class launch facilities partially operational. SpaceX will need to complete and activate at least 1 or 2 more custom-built propellant storage tanks, sleeve those 3 or 4 tanks, with 3 or 4 massive thermos-like shells. Complete thousands of feet of insulated plumbing and wiring, finish a massive launch table, install the table on a 6-legged launch mount, outfit the table and mount with an array of power, avionics, hydraulics, and fueling equipment and plumbing. Complete a approximately 145 meters, approximately 475 feet tall, integration tower, and perform the first fit checks and shakedown tests with a real booster or Starship. Only then will SpaceX be able to attempt Starship's first space launch. All told, it might not be literally impossible for SpaceX to complete all the above work in less than 5 weeks, but it's safe to say that the odds of that happening could probably make a lottery ticket blush. Regardless, if Starship reaches orbit at any point before the end of 2021, it would beat out simpler next-generation rockets like Ariane 6, ULA's Vulcan, and Blue Origin's New Glenn despite beginning concerted development years later, and with a far less certain funding situation. However, with the focus firmly on uninterrupted work at the orbital launch site, which an SN16 test campaign would have impacted, the lack of SN16 movement pointed to the overall thinking that SpaceX was firmly focused on the full-stack orbital test. A hypersonic test would involve a fueled Starship that accelerates to far greater speeds compared to the hop tests, which throttled down to the extent that Raptors were shut down in sequence ahead of the flip around. Such a test will be used to experience aerodynamic forces that the structure would have to endure during orbital launches, and fly closer to the conditions of re-entering from orbital speeds, providing vital data ahead of SN20's orbital flight. This also beckons the question about the thermal protection system tiles that will fly with SN16 should the hypersonic test become confirmed. SN16 has large patches of TPS, far more than SN15, although not yet enough for an orbital re-entry. In what has become an extremely rare occurrence, a SpaceX Falcon 9 launch was aborted less than a minute before liftoff by a fouled range. Translated, that means that a vehicle or pedestrian of some kind failed to heed strict warnings, and entered Cape Canaveral's launch range, during a live launch attempt. According to SpaceX's webcast host, the culprit may have been an aircraft that strayed inside temporarily restricted airspace. Over the last few years, range violations have become rare, as the East Coast U.S. military wing responsible for managing it, the systems responsible for disseminating keep-out zones, and general public awareness have gradually improved. As SpaceX CEO Elon Musk noted shortly after the rare Falcon 9 launch abort, the keep-out zone figuratively erected before U.S. rocket launches is large, covering hundreds of square miles, to hedge against the possibility of an in-flight rocket failure or explosion. Despite SpaceX's innovative cheerleading of an autonomous flight termination system that would terminate a Falcon rocket the second it departed a much smaller corridor, safety regulations and range management have yet to respond in a significant way. According to Musk, if that status quo remains in place without major reform, there is simply no way humanity can become a spacefaring civilization. Orbit details shared by SpaceX suggest that the company's second dedicated smallsat rideshare launch, known as Transporter 2, will also carry a second batch of Polar Starlink satellites. SpaceX launched the first batch of 10 Polar Starlink satellites in January 2021, as part of Transporter 1, co-manifesting them alongside a record-breaking 133 other spacecraft for a variety of companies and institutions. The mission was ultimately a major success, breaking records, and demonstrating that SpaceX is serious about its smallsat program. Much like company executives promised in 2019 and 2020, SpaceX really does appear to have firm plans for semi-regular rideshare missions that will give customers 2 or more launch windows per year. Thanks for watching this video, and it's a super interesting topic. If you like this, make sure to subscribe. If you have any crazy ideas about what we should cover in next video, please comment it below, and we'll see if we can get to it. So thanks again for watching and goodbye.